Hello, this is Mr. Stansbury. I'm going to take you through the 7G notes on graphing lines. At the end of this, you should be able to say I can graph linear equations and find points of intersection of multiple lines. All right? All right, so first thing, graph the line with the equation y equals 1/3 x plus 2. Okay, so hopefully you remember back from good old algebra days and everything, the first thing you probably want to do is graph this plus 2. This is the, remember, this is the y-intercept. Right, so we're going to start up here at positive 2, and then we're going to use this 1/3 as our slope. Right, so from here we're going to go up 1/3, and you can do that a couple more times, up 1/3, up 1/3, and you've got many different lines here, many different points here where you can put a line that connects through all, goes through all those points there, and you make your nice straight line, and we have graphed the line. All right? All right. Oops. Next one here, graph the line with the equation 2x minus 3y equals 12. So a couple ways you can do this. One way, the first way I'm going to show you is to solve this equation for y and do like what we just did on the first example. So first thing I'm going to do is subtract 2x from both sides. And we get negative 3y equals negative 2x plus 12. And then now I'm going to divide everything by negative 3. Right? And I get y equals, negative over negative is positive, so we get 2/3 x minus, because a positive divided by negative is a negative, minus 4. So now when I go to graph, now I can graph this here, which is, let's see, my first point is down here at negative 4, and then my next point is going to be up 2/3, right? Up 2/3, and we can keep doing that over and over and over again, and then we can graph our line through that. Okay, so that there is one way. Another way you can also do this is you can do you can find x and y intercepts. Okay, so if you're going to do that, what you'd want to do is say, if you're ever looking for the x-intercept, we know that y equals 0, and if you're ever looking for the y-intercept, the x equals 0. Okay, so if we're looking for the, let's say if we look for the x-intercept first, y equals 0. So really, when you have 2x minus 3y equals 12, if y equals 0 here, this whole piece here is gone. That goes away. So we're just left with 2x equals 12 divided by 2, and x equals 6. And there's our 6 right here. There's our y-intercept. And then if you're, sorry, your x-intercept, and if you're looking for your y-intercept, x equals 0. So this here, 2 times 0 will turn into 0. And so then you just have negative 3y equals 12 divided by negative 3. And you get y equals negative 4. So there's your y equals negative 4 intercept. So your y-intercept, so then you can, again, graph the line that way as well. All right? Okay. One last thing here is we're going to use graphical methods to find where the lines x plus y equals 6 and then 2x minus y equals 6, where those meet. Okay, so it's asking us to use graphical methods, so we'll do that. We're just gonna we'll just graph both of those and see where they cross. So I'm going to use the not the intersects, but the solve for y method here. So I'm going to solve this one for y. So I'm going to subtract x from both sides. And I get y equals negative x plus 6. So if I go to graph that, I go up 6 is my first point, and then I'm going to go, that's negative x. So that's really negative 1/1, right? So now what I'm going to do is I'm going to go down 1/1, down 1/1, so forth and so on. And there is my, whoops, that's not it. There's my line. Okay. Now if I'm doing this one over here, I'm going to also solve this one for y. So I'm going to do, first get this rolling here. So I'm going to subtract 2x from both sides. I get negative y equals negative 2x plus 6. And then I'm just going to want to get rid of that negative. So I'm going to divide everything or multiply everything by negative 1, however you want to do it, or just switch all the signs. Y equals 2x minus 6. Okay, so I'm going to go through and plot those points. So I'm going to start at negative 6. Right, and then go up 2 over 1, up 2 over 1, so forth and so on. And then there's that line. So now I can tell that here's my intersection point right here at that spot right there. So intersection is at, and we've got, let's see, 1, 2, 3, 4, up 2. So it's at 4, 2. Okay, so that's how you can do that thing with graphing by graphing it. I'm also going to actually show you just really quick. I'm going to show you how to do this algebraically. Okay, because you can actually do the same thing using algebra, and usually you're going to get more accurate answers. If you graph this really well, like we did here, we're going to get the right answer, but sometimes it gets a little goofy. So I'm going to show you that here. Okay, so algebraically, we can just line these two things up here, x plus y equals 6. And if you notice, again, this is from a couple chapters ago, if you add these lines together here, these y's are going to end up canceling out, right? They're going to end up turning into 0. So I'm going to just do that. So I go 2x plus x is 3x. That goes away, equals 12. I divide both sides by 3, and I get x equals 4. And now that I know that x equals 4, I can just plug this x equals 4 back into either one of the equations and figure out what y is. So I'm going to plug it into this one because this one looks a little nicer. So I've got x plus y I know equals 6. But now that I know x equals 4, I go 4 plus y equals 6. So I subtract 4 from both sides, and I get that y equals 2. So that way I also get 4, 2 is my answer. All right, that's all there is for this section. You should now be able to say I can graph linear equations and find points of intersection of multiple lines. If you have any questions, please ask. Thanks.